Lesson 13-2, making predictions using samples. And in this lesson, you learn to predict the actions of a larger group using a sample. Okay, and when are you ever going to use this? You can predict the number of left-handed students in your school by using a sample. Words that we are going to learn in this lesson are sample, population, and random. So let's take a look at this example in Student Council. So the Student Council at Springfield Middle School is planning a year-end field trip to either Park A or Park B in San Antonio, Texas. Since the committee does not have time to survey every student to find their preference, they can survey a smaller group or a sample. So the information from the sample will help them predict where the students would prefer to go on the field trip. So the sample is basically a smaller group. Okay, so representative sample is in statistical sampling. Don't mind the ape thing here. Okay, in which researcher attempts to select individuals which are representative of a larger population. So when you talk about representative sampling, it has to be, okay, representative of the larger population. So to be able to get a sample of students, okay, who they will ask what park they prefer, Park A or Park B, the sample should represent the entire population. Okay, so let's take a look at this one. And of all the students in the school, all of the students in the school make up the population. So in our example, all the students will make up the population. To predict the population's preference, the survey should represent the preferences of all the students. Here are some suggestions. So survey every 15th student named on the school roster. That will make it random. Okay. Survey every 10th student who exits the school at the end of the day. Okay. Survey 2 students from each homeroom class. That will best represent the population, okay, of the school. So each of these methods is a way of making sure that the sample is random or drawn by chance from a population. Okay? So when we define a population is a group of phenomena, okay, that have something in common. In our example, it's going to be a school of students. Okay, the term often refers to a group of people, as in the following examples. So a population can be all registered voters in Crawford County, all members of the International Machinists Union, whatever that is, all Americans who played golf at least once in the past year. These are examples of population because they have something in common. Okay, so but populations can refer to things as well as people. So not only can they refer to people, they can also refer to things, like all widgets produced last Tuesday by the Acme Widget Company. Okay, don't ask me what a widget is. Okay, all daily maximum temperatures in July for major U.S. cities, and all basal ganglia cells from a particular rhesus monkey. Okay, I know you all know that. Okay, so, and a sample is a smaller group of members of a population selected to represent the population. A random sample is one in which every member of the population has an equal chance of being selected. So that's our definition of a sample. Okay. For example, if you want to ask kids in school, or if you want to create a survey, what ice cream brand they like best. Okay, a good place to go would be the mall. Okay, a good place not to go would be, let's say, if you go to Baskin Robbins and ask people what their favorite ice cream is. Okay, that would be a bad selection of a sample because most of the people who go there like Baskin Robbins, and they would probably say Baskin Robbins. So that is not a good representative of the population. Okay, moving on. When you talk about, we want to know about the population. Okay, the wants of a population. And when you talk about a random selection, we are only choosing, okay, a sample or a small group of the population. Okay, so this is your whole population, and we're only asking a small group. Okay, so let's take a look at example number one, see how this works. Chase wanted to find out in which place his students would prefer to go, Park A or Park B. He surveyed every 20th student who entered the school at the beginning of the day. Is this a random sample? Answer would be Chase had no control over the order in which the students entered the school at the beginning of the day. By surveying every 20th student, he avoided surveying an entire group of friends that might all prefer the same place. This is a good random sample. Okay? Chase wanted to find out which day students would prefer to go on the trip, Wednesday, Thursday, or Friday. He surveyed a small group of people standing in the hallway before school. Is this a random sample? The answer would be by surveying a group of students standing in the hallway, their preferences may be influenced by those in the group. So this is not a random sample. Okay? And you can use the results of a survey to make predictions about actions of the entire population. So in example number 3, take a look at this one. When Chase conducted a survey to find students' field trip preferences, he learned that 48 out of the 60 students surveyed preferred Park B. Okay, so out of let's say 5,000 or 10,000 kids, okay, they surveyed 60 students. 48 out of 60 students preferred Park B. So what is the probability that any given student will want to go to Park B? So to answer letter A, okay, to answer letter A, you have 48 out of 60 of them. Okay, preferred Park B. Okay, and if you make this into a fraction, this is 48 out of 60, and simplify 48 out of 60, that will be equal to 4/5. Okay, so the probability that any given student will want to go to Park B will be 4/5, or 0.2, or 0.8, or 80%. Okay, so there's an 80% probability that a given student will go to Park B. So let's answer letter B. There are 395 students at Springfield Middle School. Predict how many students will want to go to Park B. So what we want to do is we want to use the answer that we got from letter A, use a proportion, and let S represent the number of students who will want to go to Park B. So let S represent the students who want to go to Park B. Okay, and we'll use a proportion for this. We know that the probability is 4/5, 48 out of 60. So we can do 48 out of 60, or the simplest form, which is 4/5. Sorry, make it smaller. 4/5 is equal to S out of 395 students. Okay, and we still remember how to solve proportions. We do cross products. So we have 4 times 395 is equal to 5S. Okay, and we know that 395 times 4, here's our squiggly line, that's a 20, it's a 2, 36, 38, that's a 3, 12, 15, so it's 15,000, sorry, 1,580 equals 5S. And this is a one-step equation. We learned how to do this. To be able to solve for S, we divide both sides by 5. So if we divide both sides by 5, you end up with 1s, or simply s. And 1580 divided by 5 will give you 316. Trust me on this. Okay, so out of the 395 students, okay, about 316 of them, okay, will prefer, okay, part B. All right, and that's how you solve that problem. First and foremost, you get the probability, and then get the probability, then multiply it with the number of students using a proportion. Okay? And that's the end of our lesson. Thank you for watching. Oops, sorry. The secret word is Tar Heel. The secret word for this particular lesson would be Tar Heel. Okay? Thank you for watching.